Our topic today is photoelectric effect. Photoelectric effect is the process of liberating electrons from the metal surface when light of sufficient frequency falls on it. That is photoelectric effect. It can also be called photoelectric emission, the process by which electrons are released from the metal surface when light energy falls on it. It is not light of all frequencies that can liberate electrons from the metal surface. It is the light that has sufficient frequency that can eject electrons from the metal surface. Take for example, if you have a metal, let's say iron, metal, and you release light energy, incident ray here, that has sufficient frequency. When this light falls on this metal surface, electron can be released. And this light here is incident ray. And the total energy of this incident ray is E. And this E is the product of Planck constant H and frequency of incident light. Now, the electron that is released here by light is known as photoelectrons. Photoelectron. And if we make use of Einstein's photoelectric equation, we can solve problems involving energy that is used to liberate electrons from the metal surface. So Einstein's photoelectric equation states that E is equal to W plus AE, where E is the total energy of incident light. W is known as work function. Work function. And work function is part of this energy that is used to liberate electrons from the metal surface. Ke here is the kinetic energy of the ejected electrons or photoelectrons. This total energy of incident light, as I said, is the product of Planck constant and frequency of incident light. So we can replace this E with HF is equal to, and work function here is the product of Planck constant and threshold frequency, HFO, where FO is the threshold frequency. And threshold frequency is the minimum frequency of light required to eject electrons from the metal surface. Then Ke here, which is kinetic energy, is the same thing as half of mv squared. M is the mass of photoelectron, v is the velocity of the photoelectron, V square is square of that velocity. So experimentally, we can plot a graph of maximum kinetic energy of photoelectrons against frequency of incident light. So if that happens, we plot a graph of maximum kinetic energy, otherwise called AE max. Maximum kinetic energy. We plot it against frequency. It's going to give us a straight line graph. But that graph will not pass through the origin. Rather, it will cut frequency axis at a point here known as FO. And FO is the threshold frequency. Threshold frequency. So you can see here that this axis from 0 here to this point represents frequency of incident light. But from 0 to this point, no energy, no electron is released. Meaning that it is not all frequency of incident light that can actually eject electrons. It must be up to minimum value of that frequency, known as threshold frequency. So from this region upward, photoelectrons are emitted. And if we find the slope of this graph, the slope of this graph will give us Planck constant H. This other region, from here, this region of the graph gives us work functions. And photoelectric effect has some applications. Applications of photoelectric effect. One is in photocell circuits. In photocell circuits that is used in burglar alarms and also in an automatic door opener. It can be used for opening and closing of doors automatically. There are some doors that as you are walking close to the door will on its own open for you, you pass. If you are coming in and the door is closed, if you are coming in, the door will open. Nobody touches it. It is this kind of circuit that controls it. So light is used to control such circuits. We also have it in a cathode ray tube. Photoelectric effect is applicable in cathode ray tube. For example, television camera. So, these are the uses of photoelectric effect. Remember that it is not all light or any frequency of light that can succeed in ejecting electrons from a metal surface. Such light must have a minimum frequency known as threshold frequency. And threshold frequency is the minimum frequency of incident light required to eject electrons from the metal surface.